Hello, so today we're going to be looking at section 5.4, which is on solving polynomial and rational inequalities. We've looked recently at the graphs and properties of polynomial and rational functions, but now we're going to move into the inequalities, which we've seen some inequalities earlier this semester. We dealt with some quadratic inequalities. And of course, quadratic inequalities, quadratics are a form of polynomial. They're a simpler polynomial, a second degree. And solving them is similar to solving other polynomial and rational inequalities. And so I'm going to run through an example of a quadratic as a review and show you some key features that we're going to be looking at, and then we'll move on to the polynomial and rational inequalities in the next video. And so the quadratic inequality I'm going to solve first is x squared minus x minus 12 is greater than or equal to 0. When we work with quadratic inequalities, we know that a quadratic, the graph of a quadratic is a parabola. And the parabola either will open up or it will open down. And what we're looking for is where this parabola is above the x-axis, because we're looking for it to be greater than 0, the x-axis being 0. And so typically speaking, if you have the x-axis running through your parabola, your solutions will either be on the tails when the graph goes above or in the middle. And here the graph will go above. If the parabola opens down, the graph goes above in the middle. And so we're looking for one of those two scenarios. Now here, the parabola opens up because the lead coefficient is 1, which is positive. And so we're looking at this scenario. And all we really need are the endpoints to the interval, which are the x-intercepts. So to look for the x-intercepts, we're going to set that quadratic equal to 0, because that's what we're looking for, is where it hits the x-axis, the value of 0. We're going to factor, which in this case x minus 4 and x plus 3 will factor the polynomial. And when we set these factors equal to 0, we're going to get 4 and negative 3 as x-intercepts. So if this is negative 3 on the left and 4 on the right, then we can determine the solution to be everything less than negative 3 and everything greater than 4, because that's the two parts of the parabola that are above the x-axis. However, this won't be as effective of a way to solve polynomial and rational inequalities, because those are much more complicated graphs. And so you have more to deal with, whether they open up, down, how the tails work. And so sometimes it's just simpler or quicker to use something called a sign chart, which we talked about with quadratic inequalities. Okay, so sign chart. And a sign chart, essentially, you're going to just focus in on that x-axis. And we're going to throw our intercepts on now that we have them. And we're going to separate this into 3 intervals. One on the left, one in the middle, one on the right. And we're going to pick a value in each of those intervals, negative 5, 0, and 5, because I just like those numbers, and they will work out nicely with the arithmetic. It doesn't really matter what I choose. And I'm going to see what the output is. If the output is positive, greater than 0, then we have a solution. If the output is negative, then we don't. And so I'm going to plug these in, and you can plug them into either the original or the factored form. It doesn't matter. I'm going to go to the factored form because it makes the arithmetic kind of nice. So I'm going to plug that negative 5 in for the x's. You get negative 5 minus 4, and you get negative 5 plus 3. That didn't turn out real nice. There we are. Okay, and when I multiply these, or when I do the subtraction, it's -9, and this will be a -2, and now when I multiply these, I get a negative times a negative, which is positive. It is 18, yes. However, I don't really need to know the value. I just need to know the sign to know that it's above the x-axis here. In the middle, we chose 0. I chose 0. And so I plugged the 0 in. I'll do this down a little lower. 0 minus 4 and 0 plus 3. And simplifying the parentheses. And now I've got a negative times a positive, which is negative. So my outputs are all negative here. If I try the 5, I get 5 minus 4 and 5 plus 3, which ends up being a positive 1 and a positive 8. Positive times a positive, of course, is positive, and so we end up with all positive outputs in that interval. And now when comparing positives and negatives, comparing this to our inequality, which says greater than 0, I want all the positives for my solution. So our final solution, the intervals that will work for this, are going to be -infinity to -3. We're going to include the -3 because the equal sign on the inequality. And then we're going to use 4 to infinity because that's the interval on the right end. And again, we're going to include the 4 with a bracket. This combination of intervals will be the solution to our inequality. And finally, I will move on to describe the polynomial and rational inequalities in the next video. Thank you.